My name is Kulkarni from TCS, as introduced me. So this some points of coincidence would essentially. So this is my third time in presenting at the AUTOSAR conference. Somehow I always draw the slot just before lunch. I don't know how. So growling tummies or people getting restless for food, I try to make it interesting, and we can go and enjoy our lunch after this. And it's what I've noticed, every time I come to the conference, I come with a certain topic in my head, but then usually the way discussions go, the previous day or in the mornings, there are enough links that get established to what we are doing, what we are trying to do, and what I'm going to talk in my presentation. The topic that came earlier, some questions came on the ideal part and ARXML part. 2 years ago, I had presented on this exact challenge of system definition, when you have so many disparate systems coming together, each having their own way of defining the system, having ARXMLs, ideals, process something else, adaptive something else, so on and so forth. So it's interesting to have all of these ideas coming together, and we see that the challenges still remain. Everybody's still trying to figure out what's the most optimal way of doing it. So kind of that as the background, I'll go into what I'm going to talk about today is more from using containers and sort of selling containers as one of the solutions to be able to do our automotive-based development. So maybe just as a show of hands, first of all, how many people here are actually comfortable thinking about containers and what containers would bring into the automotive world? Very few are actually comfortable. I count 3. Wow, and probably yes. Okay, I'm getting 4 reluctant hand raised there. Okay, awesome. Great. So what I will do then is, what I'm going to essentially talk about is, obviously as a starting point, just move here, come up on hiding, is obviously from typical SDB architecture, what do we see where containers are going, and then we'll take a look at a few examples. No way are these the only solutions out there or the only way to use containers. But what I wanted to bring to the audience here and kind of open up a conversation around this, how should we use this? What could be the benefits? And some of the use cases that we have tried out. And I'll refer to, as I go along, what Robert was referring yesterday from Sophie perspective, what from Eclipse XDB as well, different flavors that are coming in, sort of try to tie everything here. So, a very, very simplistic view of the entire architecture that we are seeing shaping up. We've seen dozens of versions of this already since yesterday, in the presentations, in the booths outside, so on and so forth. So essentially, the sort of the new part, and I can very easily relate since I got only 4 to 5 raised hands. That means this is still a big unknown as to what to do here. Why are we even talking about containers? Where do they fit in the architecture, and what should I do about it? So, to complete the first step is where are they going from? Today, yes, containers coming from the cloud architecture, coming down to the embedded world, and the way the technology is today sort of is implying Linux for now. I know other operating systems have brought in their own container runtimes. How prevalent they will be, how common they will be, time will tell, as usual. But that's where this is fitting. So our general purpose OS is on top of which you typically have a container runtime, which is managing all the different containers out there. So somebody has to manage it. From adaptive AUTOSAR terms, execution management cluster manages everything that is running on that particular machine. So similarly, a container runtime is managing everything related to containers. There was talk of the mixed criticality orchestration on Sophie's talk as well yesterday. So obviously it will fit in here of doing the orchestration of all of these containers. I am not going to go into details of those in my presentation today of handling mixed criticality. As we heard Robert say yesterday, 2025 is where Sophie is targeting to have a good MCDO useful for automotive usage. So that's essentially the where we see it will sit. Now, although I have shown here an HPC, of course, all of this can be run in the cloud as well. Why I've intentionally omitted it is we are cloud, Dockers, Kubernetes, containers, microservices, is old story. What we are talking about is trying to bring it here, and so I've intentionally omitted it on this slide. So what, why? And as I touched briefly on it, since again, very few hands are raised, it's obviously yet to fully mature concept from an embedded perspective. Containers and embedded domain, that's something we've already talked a little bit of the background to it. The way I see, and it was touched in Sophie as well, is the beauty of being able to use containers is for you to be able to do something in the cloud world and bring it as it is into the embedded world. If we have to redo things, okay, cloud is great, Dockers are great, containers are great. We do something, but now if you have to bring it into the embedded world and we have to redo a bunch of stuff, we've lost all the beauty of doing it in the cloud. We have lost time and effort, obviously costs associated. So the point is bring that cloud native paradigm into the embedded world. So once we achieve that, that's the real beauty, that's the real selling point of even thinking of containers to be brought here. Other typical things which everybody has talked about, containers is another way of doing it. We've talked of AUTOSAR, we've talked of entire tool chains. The presenter had a nice slide of showing everything together in terms of what tool chains can bring and how it should be deployed. So all of these are the benefits which I shall not go too much into detail, we all know this. And then obviously, like I said, bring cloud to device easily, and that's your biggest selling point. So what I want to do next is take a few examples and sort of show an architectural view and present how we can benefit using containers and the things that we have tried. So this is a completely non-AUTOSAR based container deployment. And what you see here essentially is a simplified view of something that we did with one of our customers in trying to bring containers, and as a first step we wanted it to be non-AUTOSAR. And subsequent slides I'm going to try and marry a few things together of non-AUTOSAR, AUTOSAR. But what you see here is essentially, let's say it's an ADAS use case where something is coming along the camera, there is an object detection, let's say an emergency braking algorithm running as a microservice here, and then you're trying to show whether it's working fine and the actual braking happens and the car stops on time or not. And then typical SDD architecture that we're talking about, there's something talking to the zonal controllers, which was simplicity saying I'm removed from there. So you have these microservices, and obviously all these four blocks are implying containers. So this is how it was split up. Again, to emphasize to everybody who's new to containers, how this is split is a very, very architecture/design decision. There is no rule, there is no standard. Does it mean if you have containers, you are implying microservices? Or if you say microservice, does it imply containers? It's a discussion maybe we can have over lunch. But it's about having the functionality split into the isolated silos, I would say, which can imply isolated, sorry. In the silos, where you have complete dependencies implemented within. So whatever this camera feed needs, everything is bundled here. Whatever the algorithm needs, let's say a third-party stack, which is using some ADAS features, is all bundled in here. And I have these two services just doing something for testing purposes. And you'll see what I've listed here on the right is where I'm heading next. So microservices focus on specific functionality. I covered that. All the dependencies are within the containers, which is the real beauty of containers. If you go onto the internet, and I'm going to digress a little bit, but how containers came into being was one developer did some development and gave his software to a tester, and tester tried to do it on his or her machine, and it did not work. So what's the classic software development answer? Developer says, it works on my machine. So tester says, I don't have your machine, and that is how containers are born. Can I give my machine to the tester with all the dependencies, with all the software within, and everything should work as is? So that's kind of the joke of how containers came into being. Developers complaining, hey, it works on my machine, and testers saying, well, it doesn't. So that's kind of the joke part, but that's the beauty of it. So all the dependencies are within here. And then, like I said, stack can be a custom developed stack. Now the advantage of such kind of an architecture is, let's say these two microservices are something you are targeting towards your production program as well. So you want to have this microservice as is, which is taking in the inputs, running the algorithm, doing the emergency braking, and let's say passing on the output to a zonal controller to let's actually take the brake operations. But what do you do during testing phase? You don't have this entire setup. And we talked of shift lefts and so on a couple of times already today. So this is another way of doing it. For example, now I just want to visualize this as my test setup. I can have a display rendering part connected to a physical display on my test setup, and this service is just doing that activity. This container is just doing that activity, which I can throw out tomorrow. Because finally in the car, this is not the microservice I need. So what I've put in here is the way to look at things is you can have a development versus testing versus deployment image. So you can start going one step closer to production programs with containers, but build a few things which are only needed, let's say, for testing purpose or for trial purposes or just for demo purposes, that we can have quick demos set up without having a lot of fancy setup. But this can be removed easily. So that's one of the ways of looking at this shift left with containers, bring in something that you just want to try out. But then you don't have to create a full, let's say, Linux image with all the applications within which are going to be just these two things, for example. And again, to make it clear, this is an example of how you want to actually implement it to daily use case by use case, need by need. So that's kind of the beauty of trying to look at containers as A, the isolation, B, the cloud native development, C, being able to create these test rigs built within. So this was an example that we did everything on AUTOSAR. There is zero AUTOSAR flavor here. Now, what about AUTOSAR? Now again, incidentally last year, and Gunter remembered it, he met me yesterday saying, oh, you're talking of containers again this time. So last year I had talked about very specifically on adaptive AUTOSAR to be relooked at, in very simple words, to make it more useful for containers. So what we have today is essentially, this is the architecture diagram that I'm sure pretty much everybody is familiar about. And what we are saying currently still is it relies on PostFixOS, and then on top of it is typically a container runtime, and then containers will host everything together, and which is fine. What I thought last year was it's a bit of an overkill, and we can relook at the architecture itself to utilize how we can go about doing containers in a better way. Because the way I see, and one of the topics that Michael is sitting behind as well is the value of adaptive AUTOSAR. That is one of the feedback points that was discussed yesterday. So the way I see, obviously value is large, because everything that as a standard adaptive AUTOSAR provides, we are going to need it. Whether we do it in a non-AUTOSAR way, we need something to do execution management, we need event management, we need state management, we need network management. So either you do custom solutions or you rely on a standard. So that's kind of me always being in a flavor of standardization. And an example I had quoted last year as well, and I'll repeat. Before automotive, I used to work in locomotives. So 2009, 10 time frames where I worked with a locomotive customer and revamping their entire system that is getting used within the locomotive. And there we developed a middleware from scratch, which did SOA, which was VBS based, and we implemented a lot of quality of service, and we implemented everything on Linux, so on and so forth. Adaptive AUTOSAR was not even born at that time. I didn't even know what AUTOSAR is. To be frank, I was not an automotive at that time. But now that I am, and now that I've spent so much time, I wished that the standard existed, because that is such a great reference to immediately use and build upon. Where at that time we spent so much time figuring out all these blocks of execution and health and states and process liveliness and whatnot, everything which has been baked into a standard right now. So, could have brought AUTOSAR into this particular as well. I think there was a slide yesterday morning about the parallel industries or adjacent industries where we can bring all of this. Why I'm sharing all of that is now containers and all of this probably become common, and let's look at marrying them, extending the architecture to be able to bring all of this together. So we have to do time check. Okay, so where are we going with this now? Again, an example of where I'm now mixing the two things together. I'm mixing some AUTOSAR stuff with AUTOSAR. Specifically adaptive, I'm not going into containers and classy. Let's keep that away. The main selling point is here. So what I've depicted again is the way of looking at adaptive AUTOSAR and a use case, which is a favorite use case of over-the-air upgrades for all our SDV journeys. And what I've done here essentially is kind of split it in a different way, putting it one way of how you can do A, use containers, B, use adaptive AUTOSAR, and C, achieve a use case of, let's say, OTA here. So what you can notice here is, let's say I have distributed the clusters in the different containers itself, and some things might be repeated. Let's say you need some IP on both ends of unique communication management, you repeat it here. But now UCM is the obviously the cluster from adaptive point of view, which I have running in one container. And I have a different container which is managing the actual agent communication part and then passing it along to UCM or UCM master to further take it ahead. And what you see on the left essentially is a container which I've shown intentionally out of adaptive, which is the OTA client part, which is actually talking to something that is off board or something on DOIP, and it's actually going to get the package and pass it. Now, the beauty here is A, I have spread out the cluster itself because UCM is a very specific functionality. Let's say from the previous slide, if I'm even talking about from a vehicle service functional cluster perspective or a platform service functional cluster perspective, I can spread it around the container. Relating to another advantage of containers is, let's say this implementation is today C++ based, tomorrow you have a Rust based implementation. I know it was SDV, yesterday I mentioned that Rust is going to be another interest group of great prominence coming along. So that's the beauty, right? I can replace everything using Rust, which is just sitting in this container, and everything else is transparent. None of the other entities, none of the other containers know anything about whether this was Rust or C++ or whatever. So that's the split, and let's say the container here is doing the actual OTA client part, and we know with our interactions, OTA is obviously an important part, and then there are different, let's say, vendors providing the OTA functionality, and then this helps for the OEM, for example, change in the thought process of how they want to use OTA or go to a different provider. Like for example, we have a diagnostic base going on, an HTTP base going on, and then finally, instead of DOIP, I've seen more and more instances where some IP is being used to transfer the packages as well, a large amount of data forward. So what you can have essentially is, you have this change the provider, but it is in a container-based implementation. You can still replace it and carry it forward. Now again, this is an example. This is a way to look at it. I'm not saying this is the only way to look at it, but what I'm essentially trying to highlight is use this as an advantage to have this flexibility, to be able to do development through different means, to have the opportunity to have multiple vendors, multiple entities coming together, and being able to provide something sitting in a container which has no notion of how it was implemented. Maybe one last example on this slide would be yesterday, I think, I think Michael Kulkarni was mentioning in the Eclipse SDK part, if I'm not wrong, about some driver monitoring system with 140 odd tools that had to be used. So tools is one part, but then obviously all the programming language and all the dependencies and libraries and whatnot would also have been the similar challenge there for everybody to integrate. And if you go through this cloud native paradigm brought into the embedded world, that's the beauty of having that independence brought in quite easy. And of course, my final slide, I think the time is well. So what I was trying to bring in, again, as I said, I just wanted to bring in a couple of examples of how we can benefit, how to look at containers, and essentially also expand the architecture to embrace containers part. And I'm looking forward to collaboration happening between the consortiums coming together, with Sophie and AUTOSAR working together, probably bring these things together, taking seriously bringing some more open source modules implemented. So I think I've touched pretty much all of it. This is a huge bonus, and we should definitely move towards it. Again, as I stressed, it is a very architectural and design dependent decision. So no magic formula exists. This is the right way of doing containers and microservices today. And then obviously you split the platform, relook at the platform itself, and get that flexibility, because then you have the beauty of having AUTOSAR and non-AUTOSAR components being brought together, because that's definitely the need of the hour. I don't anticipate in the near future anybody doing just AUTOSAR or just non-AUTOSAR. I expect the two things will coexist and work together. And so that's essentially the flexibility of utilizing standards, as I was trying to say earlier. I wish I knew about the standards. Would have taken somewhere else as well. But we bring in the ecosystem that already exists, which is non-AUTOSAR, but bring the AUTOSAR part together. Thank you.
Thank you, Aswad. Are there any questions?
Yes.
It's just one example, not a realistic one, I would say. Could go back some at least you draw a bold line out to that. But in reality, it could be a different version, implementation, as you mentioned, of the adaptive stack in one container and in the other container.
Absolutely.
Both containers don't know about it.
Yes.
So it's then maybe one time to communicate from one to the other.
Right, so the inter-container communication would be a thing we have to establish, and we've done it simply using some IP as well, defining those service interfaces and setting up that transparent communication. So it doesn't matter what the other versions are, because you have a clear cut, I think one of the points of API-based like once you have that architectural piece clearly defined, everything else becomes nice.
So, but just feedback to your picture, it could lead to a kind of misunderstanding. So it's quite bold. It might imply that.
I see. Point noted. Okay. Next time I'll do a better job of the picture. Thank you. Thanks for that.
One question about that.
There's one question here, and Renat seems really restless to put me in trouble.
No.
Go ahead, please.
Yeah. It was a nice presentation. If you can go back to the slide where you're showing different exactly this one.
This one?
Yeah. So here the suggestion or your proposal is to maintain the container at a software cluster level, let's say for the adaptive AUTOSAR. So each software cluster can be a container. So the question is, let's say if we have two different adaptive AUTOSAR instances on different VMs, not on the same VM, how would the container runtime react? Do we have to configure it with maintaining a binder configuration in the runtime? To do it maybe on a shared memory, the communication between the containers, or as you said, already you established it with some IP. So is there a configuration possible in the container runtime to define the kind of binding that you want to do to containers?
me check that and we can have a discussion. I don't know if you can solve it that way completely, but I'll reserve my answer not to give the wrong information.
See one question from that?
Yeah, you're welcome.
Thanks also for presentation, and yeah, always the people in the last row asking things. So one question with regards to WebAssembly. So the new version coming from January has also a kind of a container framework, which is language independent. Do you see like Docker and WebAssembly here kind of compatible, or is it working together with the cluster approach we have in AUTOSAR? What's your take on this?
Yes, I think so. I mean, essentially, cluster is more we are talking from an update perspective, so I think it should be in terms of bringing those two things together. I think that's the right way. Probably need to study it more as well, but I think it's probably going to be a good way to look at the two things together.
Any further question? See, so thank you, Aswad.